What if a measurement made today could reach backward and decide what happened yesterday? Not change the record, not erase the memory, decide it. Settle a question that, until this very moment, had no answer at all. Sit with that. I know how it sounds. It sounds like a trick of language, or a bad science fiction plot, or the kind of thing you say to sound clever at dinner. But it is a real experiment. It has been run carefully, more than once, in laboratories with real equipment and real particles. And the strangest part is not that it worked. The strangest part is that almost nobody outside the room understands what it means. Most people think the past is finished, locked, done. That whatever happened, happened, and no experiment on Earth could touch it. That belief feels like common sense. It is also, at the smallest scale of reality, not quite true. And the place where this quietly became a problem, where a machine may have reached back and helped decide what a tiny piece of the world had already done, is exactly the kind of place you would least expect. A room full of instruments, a team measuring particles, and a result that refuses to sit still in ordinary time. I want to walk you all the way through it, slowly, no shortcuts. Because the ideas are strange enough that shortcuts only make them sound like magic, and this is not magic. It is careful reasoning about a careful experiment. By the end, I think you will see the past a little differently. Not as a wall behind you, more like a page that is still, in tiny places, being written. And here is my promise to you. I will not ask you to believe a single thing on trust. We will earn every step together. Let me slow down, because before I tell you what happened, I owe you something more important. How do we know any of this? Not the flashy claim, the foundation under it. Here is the honest starting point. Everything we believe about the very small comes from a strange, humble source. We cannot see it. Not with eyes, not with the best microscope, not ever. A single particle is smaller than the light we would use to look at it. Think about what that sentence actually means. To see anything, you bounce light off it, and the light carries the picture back to your eye. But the thing we want to see is tinier than the ruler we would measure it with. It is like trying to feel the shape of a grain of sand by throwing beach balls at it. So we do not observe these things directly. We poke them. We set up a situation, we let it run, and we look at what comes out the other side. Then we reason backward. That backward reasoning is the entire game, and it works. It works so well that the whole modern world runs on it. The screen you might be reading this on, the chip inside it, the navigation that guides a plane across an ocean, all of it built on a theory of the very small called quantum mechanics, which is simply our best rule book for how tiny things behave. Here is the thing about that rule book. It is the most tested idea in the history of science. Its predictions match measurement to more decimal places than almost anything humans have ever checked. Let me put a number on that, because numbers make it real. There is a property of the electron that quantum mechanics predicts, and when you measure it, the theory and the measurement agree to about 12 digits. 12. That is like predicting the distance from New York to Los Angeles and being right to within the width of a human hair. When a theory does that, you stop arguing with it. You start trusting it even when it says things that make your head hurt. And it says things that make your head hurt. Let me give you a taste of just how humble the method is. We never see a single electron. We fire a beam of them at a target, we count where they arrive, and we build up a picture from millions of arrivals. It is statistics all the way down. We are like detectives who never meet the suspect, only the footprints. And yet the footprints are so precise, so repeatable, so ruthlessly consistent that we have reconstructed a suspect we can never touch. That is the strange dignity of this science. It asks nothing of your faith and everything of your attention. Now, alongside that rule book for the small, we have another rule book for the large. It is called general relativity, and it describes how space and time bend around heavy things like stars and planets. Not space and separately time, but a single woven thing, space-time, the fabric of space itself, which sags and curves where mass sits in it. That theory is also spectacularly well tested. Clocks on satellites tick at a slightly different rate than clocks on the ground, exactly as it predicts. If we ignored that difference, the navigation in your car would drift off by miles in a single day. So we correct for it every day using a theory about bending time. Think about that the next time a little voice tells you to turn left. It is speaking to you through a correction for the bending of time itself. So we have two triumphs, two rule books, one for the small, one for the large. And here is the wound at the center of physics, the thing I want you to hold on to for the whole rest of this. Those two rule books contradict each other. They cannot both be right, word for word, as currently written, where they overlap in the places that are both very small and very heavy, like the center of a black hole or the first instant of the Big Bang. They disagree. Ask both rule books the same question there, and you get two different answers, and one of them has to be wrong. We will come back to that. For now, just know that our confidence comes from prediction and measurement, not from anyone's authority. Nobody here is asking you to take their word. The universe is doing the confirming. And the experiment I want to walk you through lies entirely inside the well-tested rule book of the small. It is not fringe. It is not speculation dressed as fact. It is quantum mechanics doing exactly what quantum mechanics has always done, which is apparently refusing to let the past be as simple as you assumed. Picture a single particle of light, a photon, the smallest possible piece of a beam. You cannot cut light into smaller amounts than this. Now imagine you send that photon toward a barrier with two narrow slits cut in it, side by side. On the far side, a screen that lights up wherever the photon lands. Simple setup, nearly a century old. You could build a version of it in a good school lab. Here is what should happen, according to your everyday intuition. The photon goes through one slit or the other, left or right. It is one thing, it takes one path, it lands somewhere. Send 1,000,000 photons, and you would expect two bright bands on the screen, one behind each slit. That is what marbles would do. Roll a bucket of marbles at a wall with two gaps, and they pile up in two heaps on the far side. That is what common sense demands. That is not what happens. What actually appears on the screen is a pattern of many stripes, bright, dark, spreading out across the whole screen. And that pattern is the unmistakable signature of a wave. Think of two stones dropped in a pond. The ripples spread out and cross each other. Where two crests meet, the water rises higher. Where a crest meets a trough, they cancel and the water goes flat. That crossing pattern of high and flat is exactly what shows up on the screen. Not a marble going through one slit, a wave passing through both slits at once, overlapping with itself on the other side. Let me sharpen that so you feel the weirdness properly. If you cover one slit, the stripes vanish. You get a single soft blob behind the open slit, just as you would expect. Uncover the second slit, and you would think you would get more light everywhere. And you do get more light in some places, but in others you get less. Opening a second door for the photon makes certain spots on the screen go dark that were lit up before. More paths, less light. Read that twice. Adding a way for the particle to arrive can subtract arrivals. That only makes sense for a wave, where a crest from one slit can cancel a trough from the other. But here is the part that should stop you. We sent them one at a time. One lonely photon, then nothing, then another, with long gaps in between. There was never more than one photon in the machine at any moment. Nothing for it to interfere with. And still, dot by dot, over thousands of lonely photons, the stripes build up. Each single photon somehow behaves as if it went through both slits and interfered with itself. One particle, two paths, at the same time. This is the thing physicists call superposition, which means a particle holding several possibilities at once instead of picking just one. Not, we do not know which slit. The photon itself has not chosen. It is spread across both. Now here is where it turns. Suppose you get curious. You place a little detector at the slits to catch the photon in the act, to see which slit it really went through. Nothing dramatic, just an instrument that registers a passing photon. You run the experiment again, and the moment you watch, the moment you have that which path information, the stripes vanish. The wave pattern collapses into the two plane bands you expected all along. The photon starts behaving like a marble. Look away, take the detector out, and the stripes come back. Put it in, they go. Take it out, they return. As reliable as a light switch, read that again, whether the photon behaves like a wave through both slits or a particle through one depends on whether you chose to look, not what you know about it, what it is. Your decision to gather information changes the physical behavior of the thing. And let me kill one comforting escape route right now, because everyone reaches for it. You might think the detector nudges the photon, that the act of catching it jostles it, and that is what wrecks the stripes. A reasonable guess. And for decades, people tried to build gentler and gentler detectors, ones that barely touch the photon at all. It does not help. What matters is not the force of the looking, it is the existence of the information. If the path could in principle be known, the stripes die, no matter how delicate your instrument. That is the clue that changes everything. This is about knowledge becoming possible, not about a push. And that raises a question so sharp it took decades to design an experiment around it. When exactly does the photon decide? Does it decide as it leaves the source? Does it commit to being a wave or a particle at the very start of its journey and just carry that decision through like a traveler packing for one kind of trip? That would be reasonable. That would let the past stay the past. What implies otherwise is a version of this test, imagined carefully and then actually built, designed, so the choice to look or not to look is made after the photon has already passed the slits. Think about the timing. The particle is already most of the way to the screen. Its journey through the slits is over. Then, and only then, do you decide whether to catch its path. If the photon had committed at the start, your late choice should not matter. The dice were already thrown. It matters. Make the choice late, and the photon behaves as though it always knew what you would choose. Choose to look, and it went through one slit. Choose not to. And it went through both. The behavior at the slit in the past matches the choice you make in the present. The particle's history seems to arrange itself to fit a decision that had not yet been made when the history happened. Sit with how quietly enormous that is. Now let me hand you a second picture, and I want you to build it from scratch with me. Forget the slits. Think about two particles born together from a single event, a tiny burst that produces a pair. This happens naturally all the time. And it happens on purpose in a laboratory when you split one thing into two. Because they came from one source, these two particles are linked in a way that has no everyday equal. Physicists call it entanglement, which means two particles sharing a single description even after they fly apart. not two descriptions that happen to match, one description covering both. That distinction is the whole story, so hold it. Send them in opposite directions. One goes left, across the room, across a country, across a light year of empty space, if you like. A light year being the distance light travels in a year, about 6 trillion miles. The other goes right. They are now far apart, utterly separate, you would think. Here is the everyday assumption we all carry. Each particle has its own real properties, sitting inside it, waiting to be found, like 2 gloves in 2 boxes shipped to 2 cities. Open the left box, find a left glove, and you instantly know the right box holds a right glove. Nothing spooky about that. No signal race between the boxes. The gloves were always left and right. You just did not know which was which until you looked. That is the comfortable story. The measurement only reveals what was already true. It is the story your whole life has trained you to believe, and for gloves it is correct. Quantum mechanics says that comfortable story is wrong for particles. And this is not a matter of opinion or philosophy. It is a matter of numbers you can measure in an afternoon. Here is how the reasoning goes, and it is one of the most beautiful arguments in all of science. Let me build it slowly, because it rewards patience. Imagine you can measure each particle along one of several angles, like choosing which way to tilt a card before you read it. You and a partner across the room each pick an angle independently and each write down a simple yes or no. Do this thousands of times with the angles chosen fresh each round. Then you compare notes. You count how often your answers agree. The rule book predicts that if the properties were fixed in advance, hiding in each particle like gloves in boxes, then across all those angle combinations, the agreements would have to line up within a specific mathematical limit, a ceiling, a hard number. You tally how often the 2 sides agree, and if there were hidden gloves inside them, that tally simply cannot climb past it. Correlations could be strong, but not stronger than that ceiling. That is not a guess. It is arithmetic. You can work it out on the back of an envelope. If hidden properties exist, the number stays below the ceiling, full stop. So you go measure. You measure thousands of pairs. You check different combinations of angles. And the results sail straight through the ceiling. The correlations are stronger than any preset hidden glove story could ever produce. This has been tested again and again in labs on different continents, closing every loophole clever skeptics could invent. And I want you to appreciate how stubborn those skeptics were, because their stubbornness is what makes the result bulletproof. They worried the particles might be secretly signaling each other, whispering across the room to coordinate their answers. So experimenters separated the 2 measurements by such a distance and timed them so tightly that not even light could carry a whisper between them in time, still through the ceiling. They worried the measurement choices might somehow be coordinated in advance, that the angle you freely picked was secretly rigged. So experimenters chose the angles using light from distant stars and quasars, light that left its source billions of years ago, long before the experiment or the experimenters existed. Nothing on Earth could have arranged that in advance. Still through the ceiling. They worried the detectors might be quietly throwing away inconvenient results, so they built detectors that caught nearly everything. Still through the ceiling. The answer never changes. The gloves were not gloves. There was nothing hidden inside each particle waiting to be revealed. Before the measurement, neither particle had a definite property at all. The property came into being when you looked, and here is the turn that should stop you cold. If neither particle had a definite state until measured, then the moment you measure the left one and it settles into a value, the right one settles too, instantly, however far away it is. Not because a signal raced between them. Remember, Nothing can outrun the speed of light, and this respects that limit because you cannot use it to send any message. Let me be careful about that because it matters. Your own result looks completely random, just as random with your partner far away as it would if you were alone. You only discover the eerie agreement later when you two compare your lists. There is no way to force a particular answer, so there is no way to encode a message. The speed of light stands as a limit on information, untouched. Nothing travels here. The link is not a message. It is that the two particles were never really two separate things with two separate histories. They were one thing described together, and your measurement resolved the whole thing at once, which means the state the far particle had all along was not sitting there. It was pending, held open, waiting on a choice you had not made yet. The past of that distant particle was, in a real sense, not yet fixed. Let me give you the third picture, and this is the one that pushed the whole idea into the machines. Go back to the pair of entangled particles. But now, do something deliberate with the partner. You keep one particle heading toward your two-slit screen. Its twin, you send off to a separate apparatus where you get to decide later what to do with it. Follow this closely because the timing is everything. Here is the setup. The particle at the screen can, in principle, reveal which slit it went through because its entangled twin carries that which path information. The twin is like a note in a sealed envelope that says which way its partner went. Remember the rule from the first picture. If which path information exists anywhere, even unread, the stripes disappear. So this particle should land like a marble. No interference. And it does. Now the clever part. On the twin, you build a device that can do one of two things. It can either read out the which path information, actually open the envelope and learn the slit, or it can erase it. Scramble the twin so thoroughly that no one, not even in principle, not with any conceivable instrument, could ever recover which slit the first particle took. Burn the envelope so completely that the answer is gone from the universe. Let me be concrete about what erase means here, because it sounds like a metaphor and it is not. You take the twin and you mix it physically so that two possible histories, partner went left and partner went right, get folded together into a single outcome that could have come from either. Once they are folded, there is no undoing it. The information is not hidden. It is destroyed. And crucially, you arrange all of this so you make the erase or read choice after the first particle has already hit the screen and been recorded. The first particle's journey is over, done, recorded on the screen, sitting in your data as a dot with a position and a time, stamped and saved. Then, only then, you go to the twin and choose. Here is what you find when you sort the results, and this is the whole payoff, so take it slowly. For the runs where you erased the which path information, the first particles show the wave stripes. For the runs where you kept it readable, they show the marble bands. The behavior of the first particle, already landed, already recorded, matches a choice made on its twin afterward. Now, I want to be very careful here, because this is where sloppy retellings turn into nonsense. You did not travel back in time. You did not rewrite the data on the screen. The dots are exactly where they always were. Not one of them moved. Here is the subtle, gorgeous heart of it. If you just look at all the dots together with no sorting, you see a plain smear, no pattern at all, no stripes, nothing to write home about. The stripes only appear when you take your list of dots and split it into groups according to what you later did to each dot's twin. Sort them one way, and inside one pile, the stripes stand out crisp and clear. And inside the other pile, there are stripes too, but shifted so that the bright bars of one sit exactly where the dark gaps of the other sit. Add the two piles back together, and the stripes fill in each other's gaps and cancel into that plain smear. The pattern was always there, braided into the data, invisible until the sorting key arrived. And the sorting key did not exist when the dots landed. So which pattern those dots belong to, wave or marble, was decided by an action taken after the dots landed. This is the quantum eraser. It has been performed in real laboratories more than once. The results are exactly as the rule book predicts to the decimal. And now step back and look at where this lands, because this is why I dragged you through all three pictures. But there's something almost nobody sees here. Facilities that smash particles together at enormous energy, the great colliders, the machines like those at CERN, are in the business of creating showers of entangled, short-lived particles and then measuring their properties downstream long after the collision that made them. A particle is born in the collision, flies a few centimeters, decays into other particles, and those are what the detectors catch thousands of a second or less after the original event. Think about the sequence. The birth is over. The parent particle is gone, vanished, decayed into its children. Its story, you would say, is finished, sealed in the past. And then, downstream, an instrument settles a property of one of its offspring, and in doing so settles a fact about the parent that was never actually fixed while the parent existed. Every such measurement is a choice about what to resolve and what to leave open. When one of those measurements settles the state of a particle whose partner already decayed, whose history was already, you would think, complete and sealed, the same logic applies as in the eraser. The measurement in the present participates in fixing a fact about the past, not by force, not by rewriting, by finally choosing which of the pending possibilities becomes real. So did such a machine change the past without realizing it? In the everyday sense, no, nothing was undone. No record was altered. But in the sense the eraser reveals, a measurement made after an event helped determine what that event had been. The record was always there. What the record meant was still open. And a choice in the now closed it. 3 pictures. 1 photon that will not commit until you decide whether to watch. 2 entangled particles with no definite properties until one is measured. And an eraser that lets a later choice decide what an earlier landing meant. Notice they all point at the same place. In each one, the thing we assumed was already settled turns out to have been waiting on a measurement. And here is what I think is the deepest lesson, the one that took me a long time to feel rather than just recite. The problem is not the past. The problem is a picture of the past we never questioned. We picture reality as a film strip, every frame already exposed, sitting in the can, whether or not anyone plays it. The present is just the frame we happen to be watching. The past is the frames behind us, fixed and developed. The future is the frames ahead, not yet reached but already shot. That picture is so natural we forget it is a picture. We inherited it from a world of marbles and gloves, where things do have their properties sitting inside them, waiting. It served us beautifully for everything at our own scale. It builds bridges. It launches rockets. It just happens to be false at the bottom. Quantum mechanics does not fit that film strip. In this rule book, an unmeasured quantity does not have a hidden value we simply have not read. It genuinely has no single value. It is a spread of possibilities, a wave function, which is the mathematical object that holds every possible outcome together with its likelihood. That spread is not our ignorance. Let me say that again because it is the hinge of everything. The spread is not a measure of what we do not know. It is the physical situation itself. And how do we know it is real and not just our ignorance? Go back to the ceiling. That is precisely what the punch-through ceiling proved. If the spread were only ignorance, only gloves in boxes we had not opened, the tally would have stayed below the ceiling. It did not. So the spread is not a gap in our knowledge. It is a feature of the world. The photon really is passing through both slits. The entangled pair really has no separate states. And measurement is not us reading a frame that was already exposed. Measurement is part of what exposes it. It is the moment the spread of possibilities becomes one actual outcome. So when a later measurement settles the state of an entangled partner or reveals a photon's path, it is not reaching back through time to alter a fixed fact. There was no fixed fact to alter. There was an open question, and the answer got written now, and the answer happens to concern then. The past that gets decided this way is only the part that was never determined in the first place. That is the whole trick, and it is why there is no paradox, no way to send a message backward, no way to win a lottery you already lost. You cannot use it to change anything you already knew. If a fact was already settled, already measured, already read, it stays settled. You can only close a question that was genuinely still open. Let me make that crisp with a small test you can run in your head. Suppose someone read the envelope. Suppose the which path information was actually recorded and looked at by a human being before you got to the twin. Then no erasing in the world brings back the stripes. Once the fact is truly fixed in the world, it is fixed. The eraser only works on questions the universe itself had left open. That boundary is the reason none of this breaks cause and effect. And notice, please, that all three pictures live safely inside the well-tested rulebook. None of this is the contested frontier. This is quantum mechanics behaving normally, doing on a Tuesday afternoon what it has done for 100 years. The frontier, the truly unsettled ground, is what it all means. Whether that spread of possibilities is the deepest layer of reality, or whether some future theory will explain it in terms we would find more comforting, that is open. The measurements are not. That gap between what we can measure perfectly and what we can explain is the most honest place in all of physics. So let's bring it home. We started with an impossible sounding question. Could a measurement made today reach back and help decide what happened before? And we did not answer it with a slogan. We built it brick by brick. First, we were honest about how we know anything this small. We cannot look directly because a particle is smaller than the light we would use to see it, so we poke and reason backward, and that method has earned its trust through prediction and measurement checked to 12 absurd decimal places. We never meet the suspect, only the footprints, and the footprints are enough. Then the first picture, a single photon through two slits, behaving like a wave through both when unwatched, building stripes even when sent one lonely particle at a time, so that opening a second door can somehow make a spot go dark, then behaving like a plain particle through one slit the moment the path could be known, and, in the delayed version, seeming to fit its behavior at the slit to a choice made after it had already passed. Then the second, two entangled particles with no separate hidden properties, and this proven, not asserted by results that punch straight through the ceiling any hidden glove story would allow, tested across continents, with signaling ruled out by distance, with the angles chosen by starlight older than the Earth, with every loophole nailed shut so that measuring one settles the other and the state it had was really pending all along. Then the third, the quantum eraser, where a choice made after a particle has landed decides whether it belongs to a wave pattern or a marble pattern, without a single dot ever moving, The stripes braided invisibly into the data until a sorting key that did not yet exist finally arrives to reveal them. 3 roads, 1 destination. The past, at the smallest scale, is not a finished film strip. Parts of it stay open, genuinely undecided, until a measurement writes the answer. And the machines that make and measure showers of short-lived particles are doing exactly this, all day, without any drama, without any headline. Settling questions about events already gone, not rewriting the record. Deciding what the record always meant. The thing to carry away is not that time is broken. Time is fine. The arrow of time, the steady increase of entropy, the way disorder always grows and a shattered cup never leaps back onto the table, all of that stands untouched, as solid as ever. What bends is the assumption that every fact about the past was locked before anyone asked. Some facts wait. And a question that waits is not the same as an answer that hides. That single sentence is worth the whole journey. A question that waits is not an answer hiding in the dark. It is a page not yet written. Now let me be straight with you about what is still genuinely open, because that honesty is the whole point of this channel. We do not know why measurement does this. We can predict flawlessly what the patterns will look like. We cannot say with agreement what is physically happening when a spread of possibilities becomes a single outcome. Some serious thinkers say every possibility actually happens, that reality splits into branches, one where you looked and one where you did not, a real multiverse of outcomes all equally real, and no outcome is ever truly erased, only separated from you, contested, deeply. Others say the wave of possibilities is a tool for our knowledge and nothing more, a bookkeeping device, and the real world is somehow simpler underneath, also contested. Others still say the spread collapses on its own, at random, once a system gets big enough, and one day we might catch it in the act, not yet confirmed. Whether the past being open until measured is a fact about the world, or only a fact about our description of the world, that remains unsettled, and anyone who tells you it is closed is going beyond what the measurements show. And underneath it all sits that wound I promised we would return to. The rule book for the small and the rule book for the large disagree where they meet. General relativity and quantum mechanics, both magnificent, both confirmed, both breaking down together at the singularity inside a black hole and at the first instant of cosmic inflation. The place where quantum mechanics says a thing can be a spread of possibilities is the very place general relativity says space-time should have a single definite shape, and those two demands will not sit at the same table. String theory, the idea that particles are not points at all, but tiny vibrating strings living in extra dimensions we cannot see, is one attempt to heal that wound. It is a serious attempt, elegant, decades in the making, and it hints at a multiverse of its own, a vast landscape of possible universes. It is also not confirmed by any measurement, and it may not be testable with anything we can build soon, and honest people say so plainly. We do not yet know what happens inside a black hole, past the event horizon, that surface of no return, at the singularity where the equations simply stop giving answers. We do not know what came before the Big Bang, or whether before even means anything there. We do not know what dark matter is, the invisible stuff whose gravity holds galaxies together. We do not know what dark energy is, the push driving the observable universe apart faster and faster toward the cosmic horizon. Though together they appear to make up most of everything there is, most of the cosmos hidden from every instrument we own. We look out with instruments like the great space telescopes and find early galaxies more grown-up than our models expected, fully formed far sooner than they should have been, and even the ancient glow of the cosmic microwave background. That faint heat left over from the Big Bang, smoothed to a startling degree across the whole sky, hides puzzles we cannot fully close. Why so smooth? Cosmic inflation, a burst of enormous early expansion, is our best answer, and it works beautifully. And we still cannot say for certain what drove it. And the deep silence of the Fermi paradox, the strange fact that a universe this vast and this old, given the physical cost of crossing those distances at the speed of light limit, shows us no one else, waits with no answer at all. And there is a thread running through all of it, quiet but real. The fine-tuning problem, the unsettling observation that the numbers baked into physics sit in a narrow band that allows stars and chemistry and us. Nudge them and the cosmos goes barren. We do not know if that is luck, or necessity, or a hint of countless other universes where the numbers came out differently, and that is fine. That is better than fine. A finished science would be a dead one. Every one of those open doors is an invitation. Here is what stays with me, and I hope it stays with you. You are made of particles that, at their smallest scale, do not carry every fact about themselves in advance. Some of what they are waits to be decided, and that waiting is not a flaw in reality. It might be the most honest thing about it. The universe, it seems, does not keep a fully written past behind a locked door, every frame developed and filed. It keeps some questions open right up until the moment someone finally asks. We live inside a cosmos that is still, in tiny ways, making up its mind. There is something almost tender in that. A world that is not finished becoming itself, that leaves a little room, a little breath between the possible and the actual. And you get to watch it happen using nothing but the quality of your own reasoning, which is the only real instrument any of us ever had. You did not need a laboratory to follow this. You needed attention, and you brought it. Think about where you started an hour ago, with the past as a wall behind you. Look at it now, a page still being written in tiny places by the simple act of asking. That shift happened in your own mind, out of nothing but careful thought, and no one handed it to you. You earned it. Thank you for spending this time thinking alongside me, truly, from the first impossible question to this quiet ending. If you would like to keep wandering through questions like this one, I would be glad to have you subscribe and come along for the next one.